Hello to the next talk here on day 3 at 21:45. It's about OpenStreetMap, the free Wiki map, where everyone can run around with his GPS receiver and provide data. Have fun with Frederik Ramm.
Hello. Well, after some initial troubles, we're finally set up. One thing I have to say, if you want sex, you're in the wrong room. Sex is in room number 1. Okay. What is OpenStreetMap? OpenStreetMap is a wiki-style world map of everything. Wiki-style is important. Wiki-style means everyone can participate. And of everything is also important because the name OpenStreetMap is a misnomer, really. We're not only mapping streets, we intend to map everything that's interesting. Streets, of course, but also railways, rivers, bodies of water, forests, and so on, natural features, points of interest. Everything really that you need to make a nice map. Everything that you need to do routing, things like that. OpenStreetMap is licensed under Creative Commons license, CC, Creative Commons Attribution Share Alike. A license that is not really suitable for geodata, but has been chosen from the beginning, and everything is under that license now. So we have to work with this somehow. But it means that you can do everything with our data, almost everything. You can use it, download it, run any sorts of programs on it, and analyze it, create maps from it, whatever, as long as your final product is also CC by SA licensed. OpenStreetMap was started 3 years ago in the UK. Meanwhile, the community has grown from the UK to enclose most of Europe and a few places outside of Europe. We have South Africa is really strong, yeah. We have people in Australia, of course, and we have lots of data in the US. I'll come to that later, but not a big community in the US yet. We have at the moment 20,000 registered users, of which in any given week, 10% will make an edit to the data. So you can say we have 2,000 active users, and the database has currently roughly 175 million uploaded GPS points. GPS points are not the most important thing about OpenStreetMap. I'll come to that later. But that's a nice figure to see we have that much data. Now, why do we do all this? There are free maps on the internet, right? There's Google Maps. The UK, the guys in the UK started 3 years ago mainly because they were frustrated with their national mapping agency, the Ordnance Survey. They have this one giant mapping agency keeping locks on the data of the whole country. And the Ordnance Survey are really, really after people using that data for any purpose that is not really within their strict license. If you make a copy of that, put it on your website for any kind of project, you can be sure to have a letter from one of their attorneys sooner or later. So a lot of people in the US were frustrated. The data, you couldn't even buy the data because it was prohibitively expensive. So people said, well, fuck yourself, we do our own. But there are other things as well. Even the free data that's available through the free of charge data that's available through Google and so on is not real geodata, it's just maps. And if you have real geodata, like if you have the information, okay, there's a road named so-and-so connecting point A and point B, road is of type whatever, motorway. If you have all this information, then you can do a lot more interesting stuff with it than you can if you just get a map image. And collecting data is fun. It's it seems to be a thing where mostly men are interested in, this, this instinct of collecting things. OpenStreetMap does the same. We collect data, we collect streets. People drive along an area and say, "Oh wow, there's one street that's not mapped yet. Let me drive in there." And the girlfriend says, "Oh well, come on again." But it is kind of fun, and also. Even if you think that mapping is already available, even if you think that we are in a civilized world here and you can just buy a map everywhere, you will find, if you participate in OpenStreetMap, that many things on these maps are just plain wrong or missing or incorrect. So it is fun. Sometimes you feel like an explorer collecting data for OpenStreetMap. And there's also a political aspect, because as long as maps exist, they have been drawn to exert power. They have been drawn well, maybe in the terms of when wars were led, to invade foreign countries, or they have been drawn to have better defenses, or they have been drawn to exert control over a population. They have been falsified to mislead people, whatever. So whoever's in control of the maps has a certain amount of power, which is of course the case today. More and more vehicles, for example, start relying on routing software. So whoever creates that software or that data basically determines where all the cars go. So this is an example. It's not a map. It's a satellite image of a military base in the north of the Netherlands called Den Helder, and this is the Google satellite image. And you see how they have pixelized this whole area in the satellite image because they don't want you to know. So the same happens with maps. Military installations are often not on maps, or changes are done. Simply, it's not the question why someone does it. It's just, if at all possible, we don't want to be manipulated. We want to have this data for our own, and we want to have the chance to have correct data. History is full of examples of maps being used to exert power. Mapping the planet, creating the street map of the whole planet, is a kind of an area of natural monopoly, where a natural monopoly, economists speak of a natural monopoly when it doesn't make economic sense for two people to do it, or for two companies to do it, right? If there's one company which has the geodata of the whole planet, it doesn't really make sense economically to set up a second company and collect everything again. So the way our economy normally works is that sooner or later there will be a monopoly, and there will be one company controlling all the geodata for the whole world. Do we want that? No, we don't. And it's not just paranoid individuals who think that such a monopoly might happen and might be a bit dangerous. It's also, if you have followed the news, then you know that two of the largest geodata providers, TeleAtlas and Navtec, have in the recent months been bought. Navtec has been bought by Nokia, and TeleAtlas has been bought by TomTom. Both of these, of the buyers, Nokia and TomTom, feared that they would be, in the future, they would be unable, or their access to geodata would be restricted if their competitors get hold of these companies. Between them, TeleAtlas and Navtec basically have geodata for the whole world. So it's not only me who says that there is a danger of monopoly and a danger of restricted access to geodata. Some things about the OpenStreetMap project and how things work in OpenStreetMap. It's not your usual open source project. We have some things that are a bit different. First of all, OpenStreetMap has very, very little rules. No project management, no elected bosses or whatever. Also, when we collect data for OpenStreetMap, we don't have a very rigid set of classes, like you must collect these items and you must name them so-and-so, otherwise it doesn't work. Everyone can tag whatever he likes. If you're into biology and you're interested in special rare species of trees and you see one along the road somewhere, you're free to enter that in OpenStreetMap, to put a note there and say tree species equals whatever, and no one will tell you not to do it. It's difficult for many people to swallow this no fixed rule thing. Especially in Germany, we have lots of people who say everything needs to be in order. We need to have a strict schema. We need to be told how to differentiate a road of class A from a road of class B. What's the difference between these types of road? I'm standing next to a road and I want to know exactly what kind of road this is now because I want to do it right. It is a bit difficult. In OpenStreetMap, of course, there is software that makes use of the data. For example, renderers which create nice maps from the data. So if you collect data and you don't do that in the way the renderer expects, then your road might not be listed on the map that the renderer creates. But then you're free to change the renderer as well. So it's all kind of anarchy project, and you have a very high degree of freedom in what you do in that project, and it's hard initially if you participate, but it's a real good thing. OpenStreetMap is also brutally pragmatic. This means whatever works, we'll just do that. For example, we are open source people, most of us, but if someone came along and said, oh well, you know, your whole database thing will run much better on Oracle, and here's an Oracle license for you, and you can use that, and here's a server that will run Oracle, then we would probably do that. Even though even though we are fans of open source, if Oracle performs twice as good as MySQL, then we'll use Oracle. And things like that, in many, many ways, people come and say, oh, you should do this in another way, and then the community says, well, if you can show that your suggestion really has merit, then we'll just do it. And in many other projects, this is just a way to keep people at bay. If someone comes in and says, oh, I have the following suggestions, then people say, yeah, well, okay, you're just here for a week, and you have the suggestion, nice, try it out, and then come back later when it works. And then when the guy comes back and says it actually works, then he's again told to do something else. But in OpenStreetMap, if someone can really show, well, this would be a better way to do it, then next day it will be on the web page, often. So that's a nice thing about OpenStreetMap. OpenStreetMap has and needs a broad community participation. We need lots of people to enter all the data. And of course, we need lots of programmers to write software to work with all that data. Someone in OpenStreetMap once said, well, if the whole city of Berlin was deleted from the OpenStreetMap map tonight and the backup was unavailable, that's not too bad. We have unlimited free labor, which is, of course, a bit, it's a funny thing to say, but it's true in a way, because the user base at the moment grows exponentially. So even if we were to delete all our data now, it would only take half a year to have everything that was created in the past 3 years or so again. So one last thing that's special about OpenStreetMap is that many in OpenStreetMap don't like established standards. So they do XML, they use all the normal programming languages and so on, but if they are told to do something basically with some established GIS, Geographical Information Systems, some established standard from the GIS world, they often say, oh, well, that's too complex, I'd rather do it my own way. The whole data model behind the OpenStreetMap server is basically a homebrew thing, reinvented the wheel, so to say. But it is important for OpenStreetMap that everything is easy, that you don't have to learn lots of GIS terms and things to be able to participate. And that's the reason behind why many things in OpenStreetMap have really been programmed from scratch instead of using some established standard. Also for the data model, I'll come to that later. I'll show you what OpenStreetMap has got at the moment, just an excerpt. For example, that's the map of Karlsruhe, where I'm from. Karlsruhe is the first German city to be complete. Nothing is ever complete, but complete to a level of detail that you find in any commercial product. Karlsruhe is the second city to be complete at all. The first one was Cambridge in the UK. This is a screenshot from the so-called Slippy map, which works just as Google Maps work. So you can zoom in, zoom out, select an area, whatever. Karlsruhe is actually much more detailed in OpenStreetMap than it is on Google Maps, for example, and much more recent as well. For example, there is a new motorway junction that has been built and has been opened a few months ago, and that's not in Google yet. This is a screenshot of the USA. For the USA, you can say a lot of things against the USA, but their Freedom of Information Act is a cool thing, and they have this policy that any data that's paid for by the taxpayer must be public domain. So all the road data for the whole of the US is available in a data set called Tiger. I think it's published by the US Census Bureau. It's not really high quality, it's not as good as the stuff that we create ourselves using GPSs, but it's quite good, and it serves at least as a starting point. The reason why this map is so sketchy is that the import isn't finished yet. Import has started a few months ago, and it was calculated that by the time the import is finished, the US data will amount to 20 times the data that was in the database before the import started. So OpenStreetMap grew by a factor of 20 just by importing, or will have grown by a factor of 20 when the US data is imported. Unfortunately, we don't have a big community in the US yet. That has still to come. People who start fixing these things, because the Tiger data in itself has errors and is a bit old. So we need to find people to work on that, but at least we have the data. This is a university in Tehran, university area, just to showing off the Arabic script here. And also, this has not been recorded by GPS. This has been taken from aerial imagery. We have a deal with Yahoo, and they allow us to draw maps from their aerial imagery. And in some areas, they have really good aerial imagery, so we can really draw individual roads and so on. Of course, the road names have been put in by other people who know the area and who knew the names. But we are allowed to use not Google images, but Yahoo images to create our maps. This is the OpenStreetMap data for Baghdad, which has also been created from aerial imagery from Yahoo, and has all the details. You can zoom into any small road. We still need a lot of names. It's a bit difficult there, because every road has a pre-Saddam name, a post-Saddam name, and 5 other names in local script, whatever. So OpenStreetMap can cope with that. We can have different names for the same street. This is an example of the Isle of Man, Channel Island. OpenStreetMap versus Google. To be fair, if you zoom in, then Google will give you the name of the capital. Forgot the name of the capital. Can someone tell me? Douglas. Google will put Douglas here, but that's it. And the very same for Iceland. Iceland is just a spot in the ocean for Google, and we already have lots of data for Iceland. Reykjavik is almost complete. So that's a really... For places like Germany, where you have real good coverage in Google, the motivation is a bit unclear and it's difficult. Many people say, oh, why do you do it? You have all the maps on Google. And there are reasons, of course, I've told you before, but for places like the Isle of Man or Iceland or so, it's really, really a powerful thing to say, but there is no good web mapping for Iceland available, and this is the first there is. So, a quick detour on how it works. What do you have to do to get something mapped on OpenStreetMap? You need a GPS receiver. This is a very simple thing. A simple model costs 80 euros or 90 euros. It's a GPS data logger, which just records all the places you go, 1 point per second. And you also need a notepad or a similar device to record where you go. You just switch that thing on, and then you go, I don't know, the way you drive to work every day or on a holiday trip. And of course you have to make notes. You have to note down the type of streets you're traveling on. You have to put waypoints in whenever, or the best thing is to put waypoints in whenever you reach an intersection. So later on, you can easily draw that in OpenStreetMap. And of course, you can put in any more details. You can put in waypoints for letterboxes, for churches, for anything you want. Many people don't use notepads to record the stuff. Many people use dictaphones as well, and they just push a button on their GPS, and then they say, number 31, letterbox right-hand side, or something. Many people also use digital cameras. The good thing about the camera is you just take the picture, it records the time, and you can later then display the pictures overlaid on the GPS track at the right position. So when you do the mapping in the editor, then you know exactly, okay, there's a photo of a street sign that I've taken exactly here. Okay, you take the GPS, you drive around, I said that, and then when you're back home, you load the GPS track into an editor, and then you have to do some manual work, because you have to identify the GPS track alone is not enough. We need to know where a road begins, where a road ends, what type of road it was, what name it had. If you don't know the data, then of course you can put it in without information. Someone else may complete it later. It's a wiki after all. Anyone can edit it. But the best thing is if you really say, you see, this is the GPS track, and then you say, okay, basically this is a road, goes over these points, and the name is so-and-so, and it's not visible here, but you say it's a secondary road. That's one of the classifications we use. And after you've done that, you press the upload button, and everything is uploaded to the OpenStreetMap server. And from then on, it's available to people. It will take a day or two until it shows up in the maps, because the maps are not generated live, they are pre-rendered, and the process takes a while. But that's it, basically. The data model behind OpenStreetMap is you have the track points. This is the raw data that comes from your GPS. The GPS just records 1 point every hour, every second, if that's the usual setting we use. What you have to do manually in the editor is you identify the. You don't use all the GPS points to build the road, especially because you often have things like a GPS point that's a bit an outlier or something. So you put in the so-called nodes, you say, okay, this is basically how the road goes, or the roads go, and then because you have written down the names of the streets and the types of the streets, you can connect the nodes into ways, and you can say, okay, this was a residential road, it's called Schillerstraße, and it was a one-way road. This one was called Kaiserallee, and it's a secondary road. So I said before that you have complete tagging freedom. We call these things tags. So any road or any node or anything you create, you can put lots of these tags in and say, you can also say node equals, this is where I met my first girlfriend or something. You're free to do that, but there are certain things that get processed by the renderer, and these are things that get processed. So if you put highway secondary, then the renderer will use a certain style. And if you have a routing software, then the routing software will assume that you can travel faster on a secondary road than you can on a residential road. So there are certain best practices or agreements that we use. You don't have to use them. Another thing I want to say about the maps equals power thing I said before is, of course, we may get problems with people abusing the stuff. I call this result-oriented vandalism. Now assume that all the routing devices in the cars would not run on TomTom data, but they would run on OpenStreetMap data. It would be quite easy for you to say, oh, well, I don't like the lorry traffic I just change the type of road and say this is a gravel road, causing all the routers, of course, to find different ways. So this is something that we have to keep in mind. We are not that important yet. At the moment, no one uses our data for real business routing. But the time will come, and we'll have to be on the lookout for things like that. We also have our first edit wars. In Cyprus, where you will know part of the island is Greek and part is Turkish, and some people don't like that a certain city has a Turkish name and a Greek name. OpenStreetMap allows us to put in the two names, but of course when doing the rendering, one of the names has to be selected to be displayed on the map. We're working on a schema to allow the rendering of different maps, so you can say, I want my map in Turkish or I want my map in Greek, but there's something else going on here, because the guy who puts in the Greek names doesn't want the Turkish names at all in the database. He wants to erase the Turkishness from Cyprus. So it doesn't help us to say to him, oh, you can have your Greek map if you want. The thing that he is after is he doesn't want the Turkish guys to have the Turkish map. So, and it's very, very hard to deal with these things. Of course, we don't want to be dragged into all this political stuff. We just want to collect the data, and we don't want people to destroy other people's data. We might be able to learn some lessons from Wikipedia here, because I think that they will have the same problems, and we might have to look at whatever solutions they have for these cases. There are technical challenges also. The OpenStreetMap servers have the full revision history, so we can see all the changes that have been made, and we can theoretically roll back to a previous state. But that's very difficult, because unlike Wikipedia, everything's connected in OpenStreetMap. So if I roll back a set of nodes to an earlier state before someone has moved them, maybe in the meantime someone else has built some roads on using that nodes. So what will happen, right? It's very, very difficult. We don't want to do a full whole-scale planet rollback to the status of last month just because there are some guys in Cyprus went berserk. So it's a difficult thing. Some things about why OpenStreetMap is cool. Of course, everyone can get the maps or create the maps he wants or he needs. You can create special bicycle maps where all the motorways are just gray because you don't use them. You can create special maps for handicapped people. You can do whatever you want. You can create waterway maps and so on. You have all the data. You can put in special style sheets in the renderers. You can also do custom routing. Like people have done that already. A router that finds the best or the nicest route to go if you're by bike. So it tries to avoid the big roads and so on. It is also possible to have things like this in the future, which is just a mock-up here. But normally, any routing software, if you have your standard TomTom, it will only give you the roads that are legal to drive. But why? I mean, you might want to drive somewhere where it's not legal. And it's not our business to tell you what to do. You can decide whether or not you want to follow the rules of your government, right? So we will, in the long run, we will be able to, if the user says, oh, I want to try out my new Land Rover on a forest track, although I'm not normally allowed to go there, then it is possible to have a routing software that will allow you to find such routes, even if they're not legal. Another thing we all need to get out more, and OpenStreetMap is a terrific opportunity to do that. And of course, you get the source. you can download the full planet dump, everything that OpenStreetMap has, every data point, every way, is created in a large bzipped planet file every week, and you also can get daily or hourly updates to that. So, well, you don't get the history, you don't get the change history. That's hidden on the servers, but the planet file really contains all the data we have. So anyone wants to do something, anyone wants to fork the project tomorrow or whatever, you can just download all our data and do whatever you want.
How big is it?
The planet file has just passed the 2 gigabyte size limit sometime, I think, end of November. I know that because some clients broke at that point, because they couldn't handle that big files in bzip2 format. It's a large XML file that's bzipped in bzip2 and takes 2 gigabyte in the bzipped format. I think if you...
It's one XML file.
Yeah. I think if you unpack it, it's going to be something like, I don't know, 50 to 100 gigabytes.
2 weeks ago, it was 46 gigabytes.
46, the whole...
Gigabytes, after unprepared.
Okay, good. So 2 weeks ago, so it's going to be 60 today, because the Tiger import is still running. You have to, if it is 50 gigabytes now, then that means there's probably 10 gigabytes of European data and 40 gigabytes of Tiger data or so. But you can also download excerpts if you want. You can also download only the Germany part or something. I want to show you, I hope this is going to work on this Windows display, some unusual things that have been done with OpenStreetMap data, just to demonstrate things you couldn't do with Google Maps. This is a map of the local area, Karl Marx Allee, and we are somewhere here. And just a second. I hope it will show up. It doesn't. I'll wait a second. I'll give it a try. Run it on its own. Maybe it works, because that's a really cool thing. The heartbeat animation. I prepared it extra for you. It took a few hours of computing time. Well, it's not perfect, but it works. See how the beating heart of Berlin? It's not just a bitmap operation. It's really the vector data gets distorted and it gets re-rendered. So you see all the names slightly moving up and down the changed paths of the roads. So that's just, it's completely useless, but. But that's one cool thing about OpenStreetMap. It frees creativity. People see that and they say, "Oh, well, that's cool. I could do something like this." And I have another thing that's called Nightfall. It's not as cool, but you see how night falls and how everything gets darker, and the roads where the people are, well, the roads where the people are start glowing red. And you can do all sorts of things. This is how it looks in the end of the nightfall animation. And there's another thing. Some of you are old enough to have played text adventures when they were kids. And someone has actually created something. Someone has created something like a text adventure that it loads live data from the OpenStreetMap server. So if you type, it loads a tile area, but if you type in east, 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 then sometimes it will just fetch the next bunch of data from the server and then tell you are next to the Alexanderplatz Tower or something, and you can't climb tower or something. It's really a trivial thing, but it's a proof of concept, and it's just something cool that can be done with OpenStreetMap and that you can't do with other things. Oh, that's it. I hope that you have many questions.
Thanks for the talk. I have a couple of questions. I will limit it to the renderer you talked a lot about. Is it available? It looked a lot like the Google Maps renderer, the JavaScript engine you used. Is it available to the public? Can I use it on my own homepage, like the Google Maps JavaScript code?
Well, yes. Everything is possible, but you have mixed up some things. There are two different renderers we use. Both of them, you can download them. One is Mapnik. It's a program that works off a Postgres database, so you have to install everything, load everything in PostGIS, and then you can create images from that. And the other is called Osma Render, and that is based on an XSLT transformation. So basically what comes in is OpenStreetMap raw data, and what comes out is an SVG file that you can then load into Inkscape and create bitmaps from it. And but these are the two renderers. And what you said is about embedding the stuff in your web page where you want the zoomable and draggable thing. And that can be easily done using OpenLayers. OpenLayers is a JavaScript framework that allows you to do these things, the draggable maps. And we have two tile servers where you can download that. You have to configure OpenLayers to use one of the tile servers, and then it gets the tile data from there. So that's in that way you will not only use the OpenStreetMap software, but you will also use the pre-rendered tiles. Of course, you can create your own style anytime and render the world according to your own rules, and then you will have to set up your own tile server. But that's perfectly possible, and all the software is open source.
A short follow-up. If you say you have your own tile server, can I implement it? Can I use the tile server with Google Maps? They allow to use different tile servers in the JavaScript.
Yeah, you can use the Google JavaScript and point it to the OpenStreetMap tile server or to a tile server of your own design. And then, but it has been done. People have set up home pages where they have Google Map, Google Satellite, and the next button is OpenStreetMap. That works perfectly well.
Cool, thanks.
In Wikipedia, we have a project called Geodaten Project. In a German Wikipedia, I think it started. And we have, for many places, we have waypoints. And recently, we activated a JavaScript map that allows to browse Wikipedia by geodata.
The mini atlas thing.
Yeah. The Wiki mini atlas. And currently it uses the VMap 0 data, which has a very low quality. Especially in Germany, suddenly roads stop in the middle of nowhere.
The same with OpenStreetMap.
Yeah, I think OpenStreetMap is
But in OpenStreetMap you can fix it.
Yeah, that's true. But I think OpenStreetMap is far better than VMap 0 at this point already. But I have just checked some cities like Nuremberg. And so I'm asking how to connect Wikipedia articles or even images from Wikimedia Commons, which also have geodata, with OpenStreetMap. Because I think that would be a really cool feature to browse interactively a map with information about the places connected.
Yeah, there are millions of ways to do this. One of them would, of course, be for Wikipedia to change the code. I think what they currently have for their mini atlas is something they've written themselves. They could have used OpenLayers as well. So if they were using OpenLayers, they could easily just point that to an OpenStreetMap tile server, and it would work. And they would have this built in. But also, there's a lot of talk about better integration between OpenStreetMap and Wikipedia. With OpenLayers, you can have any number of points of interest plotted on top of a base layer. So another thing that we could do is on the OpenStreetMap webpage, where there is the OpenLayers Slippy map of the world, we could also put an extra point of interest layer where we draw, like Google Earth does it, where we draw all the georeferenced articles in from Wikipedia with links on them. That would be another possibility, but there are millions of possibilities how you could mix these things, right? You could also put nodes into the OSM database and say, there's a wiki article that refers to this point. Click, and then you could modify the render to have a clickable icon there, things like that. So many ways to do it. I'm not yet sure what the best way will be, but nothing hinders us to try a few of them.
I'm quite impressed with the project because I wasn't aware that, as you described, the people creating the system weren't in many cases, quote-unquote, professionals, and which in some cases seems evident that it's very much something that people create because they're passionate about it, not necessarily because it's their profession. My question is just a small detail. I was wondering how do you cope with duplication? How do you figure out that someone who's importing something, a path, that this doesn't already exist, because obviously it's not an exact measurement.
What you normally do in the editor that I have shown, the editor called JOSM. By the way, is Emi here? The guy behind has written the Java editor, which I demonstrated here. This editor allows you to download the existing data before you import anything. So what you would typically do is first import your GPS track, then download everything that already is in the OpenStreetMap database for that area, and then you would start drawing in anything the places where your track shines through is obviously where something is missing. And you might also want to correct something or so. But this is not the only editor. There are other editors as well. There's also a Flash-based live editor. This is an offline editor. You can download something and then work on it for an hour without being online and then upload your changes, which is good if you have a lot of work. It's also the editor used by most of the more experienced users. But there's an online editor where you can make simple little changes quite quickly without having to download something and so on.
And I was also wondering, are there still tools that you need? So you mentioned problems with version control, and it seems, in some cases, it still seems like a work in progress. Is there stuff that you still need, tools that you still need, where you might look for developers?
OpenStreetMap has a huge need for developers. The things currently being developed, or where we have the most activity, is really in routing software. Routing on OpenStreetMap data is a very young topic because we haven't had enough data for a long time for routing to really become interesting. Meanwhile, our data is so good that you can really say, I want to go from Munich so-and-so road to Berlin so-and-so road, and you get something that is comparable to Google. There are cases where it doesn't work, of course, but we have enough data now, so people start working on the routing thing. What we also need is, or where people are also working on, is better editors for special purposes, for example, mobile. What you really want to do is you want to have OpenStreetMap on your mobile device, and there are viewers already, and there's routing software and so on, but what you also want is, oops, there's a letterbox over there which isn't on the map, now just hit the button and put it in, without too much hassle, because the whole editing stuff that we currently have is geared more towards creating large-scale mapping, where you take your GPS, you step on your bike, and you drive around for a day, and then at night you sit down and put in all the tracks. But the little things, like I just want this little quick correction. We don't have that yet. And also, not only for mobile things, also once a place like Berlin is almost complete on the map, then you don't really need GPSs to improve the data. Then you will have people who just happen to live in the area and who say, oh well, I know there's a bakery down the road, I'll just put that in. So it would be really great if we had on the web interface, if we had ways to say, put in a node here saying bakery so-and-so, we don't have that yet. We don't have quality control things. We would really need to have some scheme where people can say, okay, I checked this area, I live in the area, I looked at it, and it seems all right. There are millions of places really where work is required, but well.
Maybe as a final comment, so especially your version control comments reminded me very much of software version control, where you have very similar problems, of course slightly different, but still very similar. And I'm pretty sure there will be people who are software developers with experience in those fields who might be willing to work on that.
The current situation is that if you have a mapping session that lasts for an hour and you do lots of changes and you upload them to the server, then every change gets uploaded individually. And they're not grouped, and you don't have sort of what you have in version control systems. You often have a commit comment where you say, I just fixed so-and-so or whatever. So this is the next step that we really need to be able to bundle changes into such commit units. And what we also need is, like Wikipedia has, the chance for people to subscribe to a certain area and to say, okay, I live in Karlsruhe, in the southern part of Karlsruhe, and I know the area, and whenever someone changes something in this area, then I want to be notified, or I want to have the chance to see a list of all these things. And that would greatly improve quality control, because people would then feel responsible for their own area, and they would subscribe to these change feeds. And you can currently subscribe to a kind of change feed, but the only thing that you will get is node number so-and-so has been changed from latitude so-and-so to latitude so-and-so, which doesn't really help you. We need some way for people to visualize changes for their local area and to be able to react to them if mistakes are introduced and so on. So that's one of the areas that's really hot, but it's something that touches on many things. The editors will need to support that. The backend will have to support it. The database. So it's a complex topic.
Okay, I have a question about hardware. Some minutes ago, you showed this data logger for 80 euros or something. I was looking at it like on eBay or some Frugal some time ago, and I could only find one model of a data logger, and it used like the old Surfstar 2 chip. Do you know, are there any more data loggers? Are there any data loggers which use the more sensitive Surfstar 3 chip? And is it any difference? Is it much difference between the two chips if you are in the city and there are like buildings which obscure the view of the satellites? Can you recommend any hardware, any specific models of data loggers which are cheap and have good sensitivity?
You want a recommendation what GPS you can buy?
Like a data, not with a display, but like you showed a data logger which only logs data every second.
Well, this is a really, wait a minute.
Yeah, that like
this one is a really low-tech thing, but I have had very good experience with it.
Can you
works
give a
quite
model
well.
number? Or?
It's called a Wintec WBT201. It's a Bluetooth. It has you can either connect it via Bluetooth to your handy or to your mobile phone or PDA, but it also has internal storage. Battery lasts for something like 8 hours, and you can record. I think.
And is it Surfstar 2 or 3?
201. This one is no. It doesn't have a Surfstar chip. It has a competitor. It isn't as good as Surfstar 3. For example, a really top-of-the-line GPS is something that I borrowed from a friend because I don't own it myself.
Are there any cheap data loggers which use Surfstar 3?
Just a second. This Garmin thing, it's GPS Map 60 CSX, and this is really good. and it has even better precision than that one. And you can download an OpenStreetMap map onto the Garmin device. So when you're on the road, you can immediately see, oh, I'm going this way, I see there's a road, it's not in there, I just go there. So this is really a very good device for mapping, but I think it costs something like 400 euros or something, and this one only costs less than 100.
So is this the only data logger with around 100 euro that's available, this one, or are there any others?
I think you have to look on. There are some comparisons on the web, comparing this to other things. There's one that's called Blue something. I forgot the exact name, which is in the same price range and which is also good. But yeah, you can't really, as long as you don't use one of the old e-Trexes, then you can't really go wrong. I mean, most of the current GPSs are quite good for what we want to do with them.
Hello. First, for the device thing, on the OpenStreetMap Wiki, there's a huge page about comparison of which device is best and so on. I by myself have a Saurus and a Navtec Bluetooth mouse, which was perfect with also some viewer of OpenStreetMap maps where you display. So any PDA device that runs Linux and can talk to Bluetooth will do it as well. Okay, and the next thing about the guy who said things about version control of geodata. In fact, in JOSM there's a component, the merger that tries to detect conflicts on downloaded data and already changed data, which is very complex. And I started it and thought, it's just like CVS or just like any conflict stuff, and it really starts to get complex when you add new roads as example, and then you download roads that and other people added in the meantime, which can happen if you have big mapping parties where 100 people spread out and try to track roads. So there's a really good research field on how to resolve conflicts in geodata. So if any of you want to work on this field, then I think Frederik Ramm has plenty of works in this. So it's not as easy as CBS conflict resolution tool.
Are you prepared to 3D data? If I, for example, want to add some data of height of a building, the altitude?
Many people add latitude information to the nodes they put in, but most times the latitude information comes from the GPS, and that's completely unreliable. So as roads are concerned, the prevailing attitude in the project is, let's not deal with the height of roads. Let's instead use, there is openly available SRTM data, basically the height data for the Earth's surface, and that can be used to find out the height of a certain road to a better degree of precision than the GPS would allow. So that's for terrain things, road and so on. If you want to have 3D stuff like a building, like Google has recently, there are efforts underway to put in, what we currently do is sometimes we just put in a node and say, there's a church here. Sometimes we go the extra mile and put the surroundings of the church in, the outline. And there are people who also put in things like number of stories equals 4 or height equals 500 meters, things like that. But we don't really have provisions for real 3D modeling, like church with a spire and a golden animal on top or things like that. That would be one of the cases where we would probably say, let us put these things in an extra database, and let us create links between the two, so that a renderer that's interested in 3D data would first download the OpenStreetMap data, and then he would see, oh, there's a link giving me an ID that I can look up in the extra database, and then I get the 3D models.
Yeah, and you're not going for 3D terrain maps now?
We have been working on projecting the OpenStreetMap data onto SRTM backgrounds, right? On a bitmap basis. Create tiles with SRTM data and then just put the roads on top. We're not currently doing real 3D modeling, but we might actually derive data, height data from SRTM data at some point in time and then add that to our roads. That has been mentioned on the mailing list that we could do that, but currently we don't really have a use for that. There is one guy who does terrain for flight simulators, and he simply takes the SRTM data and puts our data on top, modeling it on top, and then creates his terrain from that, and it works reasonably well, so we might not have to duplicate the SRTM data in our data. But it's not the last word on the issue.
2 more questions, and please short answers.
Okay. My question goes in a similar direction. Is the StreetMap data typically able to cope with the difficult stuff for routing? So, for example, you have a tunnel going somewhere below other streets, and the routing algorithm needs to know that there is actually no connection between this.
Yes, yes, that's a very strong point of OpenStreetMap compared to many other things. OpenStreetMap has topology. We know that there's an intersection between these roads, and whenever 2 roads connect, we have a connecting node, and if one way just goes through a tunnel under the whole street, then there will also be nodes defining the shape of the tunnel maybe, but these nodes will not be connected to the streets above. So we can know exactly that there's no chance of making a turn there. That's actually much better in OpenStreetMap than if you just had a shapefile or something where normally you don't have topology. So you just know, okay, there's this road and there's this road where there must be an intersection somewhere. But in OpenStreetMap, wherever there is an intersection in reality, we also have it in the data.
Thank you for your talk. We have no time anymore. Sorry.
Well, you're welcome to catch me outside. Yeah? Thank you.